Hello everyone. Today I am discussing the normalization in DBMS. It's a really important topic in DBMS and a lot of questions generally asked by on this topic. So this is the normalization part where we studied in previous chapter, previous PDF, that was like first NF, second NF and third NF and BCNF. So these are the part of your normalization. So what is it basically about the normalization? Normalization, we discussed four normal form: first, second, third and bias scored normal form. So normalization is a process that improve a database designed by generating relations that are of higher normal form. Okay. Objective of the normalization, what? To create relation where every dependency is on the key. The whole key are nothing but the key. Okay. So normalization, there is a sequence of two normal forms. First NF is considered to weakest, second is stronger than 1NF, third is stronger than a 2NF, but it's important that 3NF is collected to the 2NF. Like first it satisfied the condition of the 2NF, then it will satisfy definitely of the 3NF. Then its BCNF is considered the strongest. Okay. Also that any relation that is in BCNF is in 3NF, any relation in 3NF is in 2NF, and any relation is 2NF is in 1NF. Okay. So normalization is this, like 1NF is beside like that, first fulfill the condition of the 1NF. Same condition, if it satisfies the 1NF, then it fulfilling condition 2NF, and in 3NF condition second condition fulfilled, and in BCNF that is third fulfilled. So a relation in BCF is also in 3NF, and relation in 3NF that is also in 2NF, and a relation is 2NF is also in 1NF. So normalization, we consider a relation in BCNF to be fully normalized. The benefit of higher normal form is that update semantics for the affected data are simplified. This means that application requires to maintain the database are simpler. A design that has a lower normal form, that another design has more redundancy. Uncontrolled redundancy can lead to data integrity problem. Okay, redundancy means your duplicacy is generated inside your, you didn't resolve that, and that will increase your uniqueness of that confill to your data. First, we introduce the concept of the functional dependency. Normalization is a database design technique that organizes table in a manner that reduces redundancy and dependency of data. Normalization divides larger table into smaller tables and links them using relationships. The purpose of normalization is to eliminate redundant data and ensure data is stored logically. So functional dependencies. Functional dependencies is we say an attribute B has a functional dependency on other attribute A. If for any two records which have the same value for A, then the value of these two records must be the same. We illustrate this as like example. A is B. So this is the relation we have to given this relation we have to given. So suppose we keep track of employee email, so add employee email address, and we only track one email address for each employee. Suppose each employee is identified by their unique employee number, so we say there is a functional dependency of email address on email address on employee number. Okay, functional dependency, like a uniqueness about that, like if email number is the primary key, PK means here is the primary key, then primary ID, like ID is that like fix. Okay, functional ID is a fix. So PK is your ID, like your primary key is your functional dependency, like is the uniqueness. There is a John is a uniqueness email ID and is a email number, employee number, and it has some employee name. Okay, so employee name is connected to employee email. Employee name is also connected to the name and last name, first name and last name. So that is your unique. Must exist. Okay, means primary ID should there. Primary ID generally is a unique for everyone, because in a college people students are studying and they have a different roll numbers. If still they have different same name, two student has have same name, and how we can collect their real identity, so that university generally giving a unique ID for them, like one to roll number wise, like you have a roll number in your class, so that will your primary key identity. Functional dependency means if employee functions depend to employee ID. Three different way you might see functional dependency. First is the employee number is dependent to employee name, first name, last name, and employee ID. So is the uniqueness and employee is the primary key, that is a unique about your address. Determinant means generally functional dependency, like your employee number is dependent on the employee email. So attribute on the left hand side, where is the left hand side, that is your employee number, is known as determinant. So employee number is a determinant of employee ID. Transitive dependency consider attribute A, B and C, and where A is dependent to B and B dependent to C. So indirectly we can say like B is a source where we are providing the relationship A to C. Yes, so B is a middle part. So functional dependencies are transitive, which means that we also have the functional dependencies A to C, where we say C is a transitively dependent on A through B. Clear? Transitive dependency means employee num is like employee department number is a dependent to the employee, like we are reading from here, department number is a dependent to the employee number. So here these three things, like this is the transitive dependency. Okay, so here is a department number is dependent to, like department name is dependent to the department number, but department number is dependent to which department, employee name and employee ID. Clear? Both. So these are connectively dependent to the department name also, because employee number and employee email is indirectly connected to the department name, because department number is connected to this. So this is the transitive dependency. So department name is transitively dependent on employee number via deploy department number. So employee number, like department name, is directly transitive dependent on the department employee number. Clear? Partial dependencies. These technically we have to resolve from first, second and 3NF, so that we can make a correct data inside the table. Partial dependencies exist when an attribute B is functionally dependent on an attribute A, and A is component of multi-part candidate key. Clear? Here is the candidate key is EV. This is the first candidate key. This is second line number. Clear? Both are the candidate key here. So this candidate key is a partial dependent on these both. You can see this candidate key in date is partially dependent to int v number and line number t. So as int v number is a determinant of int v date, so and int v number is partial of the candidate key. So this is also we have to remove from that. First normal form we say a relation is in first NF is all values stored in a relation are single valued and atomic. We do not be redundant here, because this is the uniqueness of your data. First NF places restriction on the structure of relation, value must be simple. So first normal form is your simple, like first 1 2 3 4. This is the conflicting, because in this table we see there is a true value of identity showing the multi-valued field. So this is not correct. So we have to be normalize this. So to obtain first relationship, we must, without loss of information, replace the above with two relations. See next slide. That is this. Clear? So these are the uniqueness and simple and correct your data is the atomic data. Atomic means single. So an outer join between employees and employee degree, we produce the information we saw before. Clear, because there is showing a uniqueness and there has a unique identity provided by the employer. Next, bias code normal form. Bias code normal form is defined very simple. A relation is in BSNF, is it in first NF, and if every determinant is a candidate key. If our database will be used for OLTP, means on line transaction processing, then BCNF is our target. Usually we meet this objective. However, we might denormalize 3NF, 2NF or 1NF for performance reason. Second normal form. Second normal form is in the first normal form, and every non-key attribute is fully dependent on each candidate key. That is, we don't have any partial function dependencies, okay, because we resolve the transparency, transitivity, partial dependency from in first NF. So right now we are on the second normal form, so it's fulfilling the condition which first normal form. Second normal form both involve the concept of key and non-key attributes. A key attribute is any attribute that is part of key. Any attribute that is not a part of key, it's a non-key attribute. Relations that are not in BCNF have data redundancy, means conflicting, it's not correct. A relation in 2NF will not have any partial dependency, this is must. Second normal form, consider this in V line table in first normal form, means there is no any partial dependency, there is no any transitivity, okay. So INF and line number is product number and quality is dependent on these. So there is a two candidate key. So quality is the only non-key attribute and it is dependent on INV number. So since there is a determinant that is not a candidate key, so int v line is not BCNF. So int v line is not 2NF since there is a partial dependency on int v date on int v num. So int v line is only in 1NF. Okay. So int v line is not fulfilling the condition. Second normal form, like in the above relation has redundancy, the invoice date is repeated on each invoice line. So we can improve the database by decomposing the relation into two relations, that is thing. Okay, this is the previous, this is the thing. Right now this is good for that. So question, what is the highest normal form for these relation? Is the following relation is 2NF. So this is the product, like BCNF is the highest relation, like we have to fulfilling the BCNF conditions, and that is the following relation is 2NF. It's yes, because candidate key should be like these partial keys are dependent to the candidate key fulfilling. So there is a INV number and line number, both are candidate key fulfilling that condition. Okay, 2NF but not in 3NF nor in BCNF. Yet these fulfilling the 2NF but not in 3NF and BCNF. Employee department, these since D number is not a candidate key and we have D name dependent to D number. Clear? Third normal form. Third normal form is a relation in 3NF, is the relation is 1F and all determinant of non-key attribute are candidate key. That is for any functional dependency, y dependent to x, where y is in non-key attributes or a set of non-key attributes. X is a candidate key. This definition of 3NF differs from BCNF only in the specific of non-key attribute. 3NF is weaker than BCNF, so BCNF requires all determinant to be candidate key. So a relation in 3NF will not have any transitive dependencies of non-key attribute on a candidate key through another key attribute. Third normal form, consider this employee relation, like candidate keys are like employee number and employee name, these are candidate key, and dependent department name is dependent on this. So employee name and department name are non-key attributes. So department number determines department name. So a non-key attribute and department name is not a candidate key. Okay. So third normal form is this. So there is something. So we correct the situation by decomposing the original relation into 2 3NF relation, not the decomposing This is the department key, and this is department name is dependent to the candidate key, that is your department number. Clear? Because this is the conflicting the relation. This is there is a no any department key. Inside the department key is your employee name. Okay, that is dependent on the this verified two relations in 3NF. So 3NF is the instructor teaches one course only, student take a course and has an instructor, because student take a one course only and instructor take a one course only. So student number, student is an instruction number. So since we have instruction number and course number, but instruction is not a candidate key here. So there is a instruction number BCNF, and instruction number is that depend on the student and depend on the code that is satisfying your condition. So it is all about the normalization, and it's the basic condition for how we resolving the things like is to an F. Firstly, satisfy one F condition, that is a partial, and your transitivity condition, and that is fulfilling the second, that is your functional dependencies, removing that and following the candidate key, and in fulfilling the 3NF condition, then is your BCNF. Okay, so these things you have to read inside it.